Hello?
Hello?
Calc 2? No, wait, Calc 1, sorry. Calc 1. Okay, so now 4.2, we're doing theorem locating extreme values. So let f be a function that is continuous on a closed interval a to b. How do I know it's closed? Bracket, thank you. That's important to understand. Okay, I'm not gonna assume you guys already understand that, but yeah. So bracket. Then the absolute maximum value and the absolute minimum value of f are the largest and smallest values respectively found among the following. The values of f at the critical numbers in the open interval. Okay, that's important. Value of f at the critical numbers at the open interval from a to b. So is it possible to have a critical number at the end? No, that's what it's trying to say. Okay, but it is possible for it to actually be a maximum or a minimum. So if f of a and f of b are the values of f at the endpoints a and b. Okay, so it could be, it could be the endpoints there. So we have to check the endpoints when we're talking about something like this. Step 1, locate all critical numbers in the open interval from a to b. All critical numbers. So take the first derivative, set it equal to 0. Thank you. Bless you. Bless you. Okay. All right. Step 2, evaluate f at each critical number and at the endpoints a and b. So it's possible for the endpoints to be one of those values of mins or maxes. Okay? The endpoint could be a max or it could be a min. So checking each. 3, the largest value is the, bless you again, is the absolute maximum value. The smallest value is the absolute minimum value. Hello?
Hello.
Good. Okay, find the absolute maximum and the absolute minimum each function. So I am going to insert a new page here so I can work on this. Page after. Okay, so my function was x cubed minus 6. Okay, so there we go. Hold on. So it's x cubed
Minus 6 squared plus 9x plus 2
on closed interval 0 to 2.
0, 2,
0 to 2.
like that?
Yeah.
And that's my f of x, right?
Yeah.
Okay. All right, so step 1 said what? Wow, that was, okay. It's like 2 different languages there. Locate all critical numbers. So now critical numbers says to do what? Find the derivative. Derivative, find the derivative. So find the derivative of this one, okay? So, yes, these ones right here actually are part of it, but that's actually part of our graphing too, okay? So there's all kinds of things you guys could find from this. Anyway, all right, so for this one right here, when we're locating mins and maxes, we're looking for the critical numbers. So now, take the first derivative. 3x squared minus 12x plus 9, right?
Yeah.
Now, what did I say to do? Factor and set it equal to?
0.
Thank you. So 0 equals, so take out a 3, I'm left with x squared minus 4x plus 3. What are the factors of 3, positive 3, that add up to negative 4? Negative 3 and?
Negative 1.
Very good, negative 3, negative 1. So 0 equals 3 quantity, x minus 3, x minus 1, Jess. All right, so from there, where are my critical numbers going to be?
3, 1.
X is 3, positive 3 from here, and
1.
positive 1, right? Okay. Serious issue. What is my issue?
It has to be on difficult.
She's got this. Go ahead. You got it.
I'm guessing. Is it because if we put
Okay, yeah.
No.
Yeah, look at my numbers. Okay. All right. My interval's from 0 to 2, right?
Yeah.
What's the problem I have?
It seems like 3 is not like this.
3 is outside of my interval, right?
Mm-hmm.
There we go. 3 is outside of my interval. So do I include 3 in what I'm doing? No, because I'm only talking from 0 to 2. That's it. There's critical numbers. Now let's go back. What did the other step 2? Evaluate f at each critical number and at the endpoints a and b. Okay, evaluate f. So that means it's going to be f of 0. And it's going to be f of 1, right? Because that's this one right here. And I can't use this one, right? No, bad. And it's going to be f of 2, the other endpoint. So I plug it into my original. So if you notice, it's not f prime, it's the original, right?
Yeah.
Okay, so plug it into the original. And so I'm going to get f of 0 gives me 2. F of 1, what's that? 1 minus 6.
6.
Gives me 6.
Yeah.
Okay, I'll take your word. Positive 6. All right. And f of 2. What'd you say? So 8 minus 24 plus
It's
18
4.
plus
Oh,
2.
it looks like 0. It's 4.
Is that negative 6, 2, 2, 4? Yeah.
Oh, yeah, it's just
Okay. All right. What is my min?
2,
What is my max?
6.
Wow. Come on, board. Come on. Come on. You can do it. Come on. You can do it. You can do it. Ah! All right. Okay. So this is my min and this is my max. ¿Está muy fácil?
Yeah.
Sí. Sí. Está muy fácil. All right. I'm going to insert one more page because I want to do the next one.
Okay.
All right. So right here. So it's going to be all of that from 1 to 10. So you guys are going to read that to me, okay?
Okay.
So what's that say? It was g of x.
2 to the 2 thirds.
What is it?
X minus 2.
X minus 2.
2 thirds over x from open period, close period from 1 to 10.
Come on, board. All right, 1 to 10, right? All right, that's important.
Yeah.
Okay, look at the function.
Yeah.
What is one thing I do not like with that function?
Everything.
It's a fraction?
Fraction, thank you, fraction. That is a good start. What can I not have in a fraction?
0.
0 where?
On the bottom.
On the bottom, 0 in the denominator. Cannot have that, right? Okay, so is 0 outside of my interval?
Yeah.
Yeah.
Yeah, that's good, that's helpful. Okay, so I'll have to worry about that. Isn't this going to be a radical to the 2/3 power?
Yeah.
That is going to be a radical, right?
X is more than
But
0.
if it's going to be, so this is what it actually says. It's a of x minus 2
Oh, we don't care.
squared, right here.
Yep.
That's what it actually means, the fractional exponent.
We don't care.
That's just the top, right?
Yeah, that's just the top. That's just the top. Now, there's a slight issue with this.
We don't care.
If it is a even number root, this is the third root, right?
Yeah.
Even number root, you can't have negatives, right? You cannot have a negative inside there. You can't get a negative out into there. So that's the issue that we cannot have, right?
But it's not.
It's not going to be one though, right?
So we don't care.
And that's, but I'm trying to make the point. You have to test that to look at it. Okay, is there anything here that I do not like? No, this one's okay. There's not going to be any restrictions on this. No restrictions on that. So that one's going to be fine. All right, so After that, what did I say to do?
No, it's derivative.
Find the derivative. Let's do that. Find the derivative. Okay, so this is going to be my f, and this is my g. F prime is going to be the chain rule. 2/3
X minus 2 to the 1, -1
-1/3,
third.
right? Because I'm subtracting 3/3. Subtracting 3/3. Okay, and then times 1, which is the derivative of the inside, right? Times 1. Okay, so now g prime is going to be
1.
just 1, right? So quotient rule here. Quotient rule. So it's going to be f prime 2/3 x minus 2 to the -1/3, right? Times x, right? Minus f prime, which is 1, times x minus 2 to the 2/3. I didn't write the 1. I didn't write the 1.
All over x squared.
All over x squared. Yes?
Yes.
Okay, very good. All right, this is 4.2. Are you looking for it? Okay. You have it? Okay. All right, so right here, here's the derivative. I'm going to clean this up. So it's going to be, now on top, because that negative exponent, I'm going to move that to the denominator with the 3 here. So I'm going to keep all this right here. So it's going to be 2x, because there's that x, over 3 quantity of x minus 2 to the 1/3 minus, good day. Hold on, let me see. Not here, is here, not here, is here, and here. Okay. Hannah and Zanab. All right. Okay, probably. No, wait, Amanda and Zanab. There we go. All right, so this is going to be x minus 2 to the 2/3 over 1. And all this right here is over x squared. So I wrote this like this because it's going to make it a whole lot easier. Okay, we're going to have to combine these together. We're going to have to factor this. And to factor this, I need to be able to combine. So my first issue here, because this is my g prime of x, again, g prime of x. So that's all of that right there. Okay, so what can I not have here?
0.
Can I have 0 there, right? Okay, I can't have 0 there. Now let's take a look again. So I'm going to bring this over to a new page. So hopefully you have this written down, because I don't want to. So it says, so g prime of x was 2x over 3 x minus 2 1/3 minus
X minus 2 to the 2 squared over 1 divided by 2 divided by x squared.
like that, okay? Again, my domain was what? 1 to 10 on a closed interval. 1 to 10 closed interval. So now, set it equal to 0. So again, I cannot have 0 here, right? Okay, so that's fine. That's going to take care of that. So I'm going to take care of that. So 0 product, so it's going to be 0 equals, so I'm setting it equals 0. 2x, 3, x minus 2, 1/3 minus x minus 2, 2/3 over 1, right? Because I multiply both sides by x squared. That's going to get rid of my x squared, right? Because 0 times x squared goes away. Yeah? Now, look at my denominators now. I cannot have what in the denominator in a fraction?
0.
0. Let's take a look here. So, since I cannot have 0 in the denominator, is there a place right here where I cannot have?
Yeah.
X minus 2 should
X cannot be 2, right? So this is for my derivative. So because of this, so it's going to be f prime of x cannot equal 2. So it cannot be that one. So that's going to be another critical point. Because critical points are not just where it's equal to 0, it's also where I cannot take a derivative at. Okay? This is going to be a critical point for this. All right, so now, common denominator, it's going to be 3x minus 2 to the 1/3, right? So on this one over here, this right here, I'm going to multiply both sides, top and bottom, by that. But if I have a quantity to the 2/3 times a quantity of 1/3, what do I do when I'm multiplying? What do I do with my exponents? Sum, I add them, right?
Yeah.
When I'm multiplying, I add my exponents. So 2/3 plus 1/3 is going to give me just 1, right?
Yeah.
That's going to help me out here. So it's going to be 2x minus, so I'm multiplying this, right? So I'm multiplying this one right here times up here. Because it's going to be part of my denominator, right? So it's going to be 3 quantity x minus 2, right? And it's going to be to the 3/3 now. Yes? 3/3, which is just 1, so my fractional exponent goes away. All this is going to be over 3 quantity x minus 2 to the 1/3 equals 0. Yes? Okay, so right there, because this is what I did right here. So I multiplied top, bottom, 3x minus 2, 1/3. So I multiplied like that because I have to have common denominators there. So I just made that happen. So now, everything in the denominator, again with the fraction, since I'm trying to set it equal to 0, I could actually clear out the entire denominator again. Right? Multiply both sides by 3 quantity of x minus 2 to the 1/3, right? Yes. So I'm going to multiply both sides by that, and so that goes away. So I'm now going to have 0 equals 2x. Now I'm going to do my distribution, right? So it's going to be minus 3x plus 2. So now I have 0 equals negative x plus 2. So x equals 2, right? So either side you move it to, right? If you move the negative x to the left-hand side, it's going to make it positive, so you get x equals 2. So now this is my critical point, right? So my critical point says it's going to be equal to 2 somewhere. So it cannot equal to 2, right?
Yeah, what it's 2, it should be plus 6, no?
Yeah.
Minus 3
Yeah.
minus 2.
That's, yeah.
Oh, you're right. I'm sorry. Thank you. You know what? I'm going to throw some candy at you for catching that one. Good job.
I did too, can I go?
No.
No, I didn't do that. No mumbling. There we go. Okay, so we should be 6 right here. All right, so that's going to be plus 6 right there. Yes, thank you. All right. Okay, so now I get x equals 6. There we go. So that means I have a critical point at x equals 6. So that's going to be a min or a max, right? That's going to be a min or a max. So I have my critical points. My critical points right here. So I have a critical point at 2. I have a critical point at 6. And I have my endpoints 1 and 10. Yeah? All right, so I'm going to show you guys in the calculator how to check this one a whole lot easier. So in your calculator, you guys are going to try this. So we're going to have, let's see, documents, graph, right here. So now we're going to this. So my function, control divide, so it was parentheses x minus 2, close, raised to the 2 over 3, right? All that's over x. Let me see. And interval from 1 to 10. All right. Hit enter. So I got a graph right here. There's my graph. Okay, so my interval from 1 to 10. So watch this. I'm going to show you guys a neat trick here. So once you get that there, I am going to go back to my regular scratch pad. Okay? I'm back on the regular scratch pad. So now this is the thing called vars. This button right here, I'm going to hit it. It's called vars, and it's going to say F1. That's going to refer to the function that I plugged into my graph. So you could actually have a bunch of different functions here. So if I want to have the derivative also in there too, you could actually check those. Okay? So right here, so what was my endpoint? So I'm going to start at 1, right?
Yeah.
So f of 1, 1. What was my next one? 2. Remember, the function is not undefined. Only the derivative is undefined. Right?
If derivative is undefined.
So yeah, that's a critical point because I cannot take a derivative at that point. You'll see it. I'll explain it here in a moment when you look at the graph. Okay, what was the next one? 6? Okay. And my last one is 10, right? All right, so this is going to be what? This has the decimal. Watch this. Okay, enter, and then I'm going to go control divide, 0.4. So I was able to actually get a decimal because I got a decimal here anyway, right? All right, so what is my minimum?
2.
It's going to be at 2, right? So my minimum is going to be at 2. My maximum is going to be at
1.
At 1. Let's go back to the graph. Now, see this right here? It's changing direction right here. This would be a kink in the graph. So I cannot take a derivative at that point. It is a kink of the graph. So let me zoom, setting, and it's going 1 to 10, right? Okay, 1 to 10. I'm going to change my Y values to make it look a little bit better. All right, let's go -1, and let's go 3. There we go. So see this right here, that is a kink. This is where it's actually changing in direction. So the slope here, so it's going negative, negative, then all of a sudden it changes direction at that point. So that's going to be a critical point right there, and then all of a sudden it goes positive. So that right there would be like an absolute value function. Okay, that's what that means. So you're gonna get a V shape out of that. So it's a pointy point that you cannot take a derivative at.
Can I ask,
Go ahead.
like if the derivative in some point is undefined, so on graph it's always going to be 0?
That's a critical. Nope, it's
Like,
not always going to be
like
0.
The f is going to be equal 0 at that?
No,
No?
no, it's just you're gonna have a kink there.
Okay.
So yeah, you'll have a kink of it for whatever reason. And so there is going to be a kink. It's going to come down and back up. I think there's one in the notes. Here's one right here. See this right here? It's not always going to be a 0. Here's the kink. We talked about this one on Friday. Does that make sense now? Of what a kink is? You can't take a derivative there, but the function is equal to. All right, so now that we use the calculator for this, we know that, so f of 1 is my max, right? And my f of 2 is my min. All right, I'll leave you guys off there. So we'll work on more of this on Thursday.